So this next video is about simplifying algebraic expressions. So let's look at our learning goal. It's to use what we know about operations of numbers and apply it in algebra to manipulate equations and expressions. And the reason we do this is to reduce complexity of equations and expressions, to make them easier to work with and easier to solve equations later. So let's look at the first part of that topic. So it's like terms. You may recall some of this from last year. Like terms contain exactly the same pronumerals, which are the letter components of the equation. So a coefficient of a term represents how many groups of pronumeral there are, as indicated by the operation. For example, if we have a look at one of those, 3x means there's 3 lots of x. And that's important. We can add groups of like terms together. So if we have 3 x's and 2 x's, that's like 5 x's. Let's have a look first to make sure we understand how to identify like terms. So this is from your textbook. We're just going to have a quick look and identify those things that have the same terms. So you may pause this and have a go yourself. So let's have a look. For y, what variables have the same terms? So it's things with y in it and only y. So that there is the same. That's 4y, that's 1 lot of y. This one here is negative 1 lot of y. That's got x's, this has got 4 x's and y's. So they're different. This one's negative 4 lots of y. So those three are like terms for 4y. 5xy is next. Let's have a look at that. Things with x's and y's are this one. This one doesn't count. This one does, because order of operations says that we're multiplying. It doesn't really matter which order we do it in. For instance, let's just have a quick look and a reminder. 3 times 2 is the same as 2 times 3. They both equal 6, which is why this is allowed. So let's keep working. This one here, negative xy, is negative 1 lot. This is not the same. X squared is not the same as x. And nor is this one, because it's actually xy times xy, which is x squared, y squared. So putting the pronumerals to the power changes the term. So let's have a look at C. You may pause and have a go now as well. This one is the same. It's a like term. It's actually exactly the same. It's negative 6 lots of, if you reorder those pronumerals, A, B, C. This one here is the same. It's got 1A, 1B, 1C inside. But this one here has got an A squared, which is different, and this one's got a C squared, which is different. Okay, and finally D, we're looking at things with Q squareds, B cubes, E to the 4th. Q squareds, the Q's match, B's and E's don't. B cubed, E to the 4th, Q squared. That one is a like term, even though it's in a different order. Q squared, E4, B cubed. That one is a like term too. Q to the 4 doesn't match Q squared. And over here, Q squared, B squared doesn't match the B's. So it's only those two. Let's move on. So they're like terms, and there's the textbook's version of it. Okay, let's look at some examples of how to simplify. So we're going to start by looking at grouping like terms. So that's basically addition and subtraction. So what we need to do first is identify our like terms. So in this case, they are the 6x minus 4x, 5y plus 2y. The minus stays with the 4. There's another one, and a third one, and a fourth one. Let's look at the first one first. Identify like terms. Feel free to color code, highlight, underline. So I've done it like this. 6x, negative 4x. They go together. 5y plus 2y in green. So 6x's take 4x is 2x. 5y plus 2y is 7y. So we group them together, because that means there's lots of. Here's our second one. So this time we're looking for like terms. A squared b, there are no others. AB squared, there are no others. And 2AB, there are no others with those same pronumerals. So in this case, There are no like terms. Okay. This one here, are there any like terms? There are. The B's there and there. So we need to add those together. Now notice that the 5 is -5, so take 5. So we're going to subtract it. So group them in green. Here we go. So 6a squared comes straight down, 7b squared comes straight down. 9b take 5b is 4b, because we've reduced the number of b's in that expression. Next example. What are our common terms? Well, in this case, it's this one here, a squared, and this one here, a squared with a b. So they both have an a squared, both have a b, so they've got the same pronumerals. We also have these two. They're constants, but they're like terms, because they have exactly the same pronumerals. Now notice that this one here, the order is different, but as we said before, the order doesn't matter when you're multiplying. It's called the commutative law. So, let's have a look. If you like, you can reorder those terms to make them look exactly the same. So we group the green ones together, which are the a squared b's. We'll group the blue ones, which are the constant terms. So in this case, 12 plus 2 is 14. That negative, remember, stays there. Minus is like adding a negative. So that's take 4a squared b. Take 2a squared b is take 6a squared b. Because minus 4, take another 2. So that's addition and subtraction. When multiplying and dividing, there's a few other principles. But mainly, when we multiply terms, we remove the multiplication sign. That's the first thing. It's an extra thing we don't need to write. We've already talked about that earlier when we talked about area of a rectangle. Length times width with the multiply sign could be written as LW. And if terms have the same base, we can use our knowledge of index laws to simplify. So we understand that if you multiply x by x, we get x squared. So here's some examples. We're going to work through these one at a time. So here's our first one. So we have a's, b, and so on. So when you multiply a by a, remember the order doesn't matter, we can switch them around. So you may wish to reorder them like this. With our coefficients at the front, multiply them together, with our a's and then our b's. And then use our index laws. 4 times 2 is 8, a times a is a squared, and b just sits on the end there by itself. We don't need the multiply signs because we understand that that means multiply each of those terms together. So that's the first example. Let's look at example 2. In this case, we've got a few negatives as well. But same as before, rearrange, apply index laws if needed. And we'll keep our negatives with the coefficients. So it's 7 multiplied by the -6 multiplied by the -2. We've got 1a, 2a's, 1b, 2b's, 1x, 2x's, 3x's that we're multiplying together. So we use our knowledge of index laws now to simplify that further. So first thing, 7 times 6 is 42, times 2 is 84. We've got a negative multiplied by a negative is positive, times another negative, times positive is positive. So that's 84. And we have a times a is a squared, b times b is b squared, x multiplied by itself 3 times is x cubed. And traditionally we put them in alphabetic order for those pronumerals. One of those conventions we use in mathematics. Next example. This is a division one, so same as before, we just use our index laws. Okay, so there's a couple of ways we can look at this. The easiest one is just to cancel out common factors. So in this case, we're going to cancel the y pronumeral. And we're going to cancel out the common factor of 4 and 10, which is 2. So 4 divided by 2 is 2. 10 divided by 2 is 5. The y's cancel out. We're left with an x in the numerator, z in the denominator. So that's the easiest way. We could also use our index laws. Y to the power of 1 divided by y to the power of 1 is y to the power of 0, which we know is 1 from the third index law. Here's another division one. It's written a little bit differently. If you like, write it as a fraction with its components beside each other. So we have 8 divided by 16, a divided by a squared, and b divided by b. So we cancel out anything that's common. So here we cancel 8, because 8 divides into 8 and 16. Here we divide by an a to get rid of the power, so that's actually 2 take the power of 1 here. And then the b's cancel out as well, same as before. So we're left with a half from the coefficients, 1 over a, because a divided by a is 1. And then here we have b over b is 1, because when you divide a number by itself, it's 1. And remember, Crow numerals are just numbers, they just don't have the specific value. So we combine them together using our knowledge of fractions. Multiply the numerators, multiply the denominators. So that's 1 over 2a is the answer. So that's the end of that lesson. So by now you should know how to use simplification of like terms using addition and subtraction by grouping like terms, and your knowledge of index laws and cancelling common factors for multiplication and division.